Hello and welcome to part 3 of the IGCSE Chemistry 2023 Specimen Paper 2. We are on question 28 and we will finish the paper in the screencast. So check out the other previous 2 screencasts if you haven't watched them yet to catch up with the first 27 questions. We continue with 28. Which statement about the extraction of iron in a blast furnace is correct? Calcium oxide reacts with basic impurities. Carbon is burned to provide heat. Iron 3 oxide is reduced to iron by carbon dioxide. And the raw materials are bauxite, limestone, and coke. So the correct answer here is B. Why are the other answers incorrect? So calcium oxide itself is a basic oxide. It's a metal oxide. Most metal oxides are basic, and it will react with acidic impurities in the furnace, specifically silicon dioxide to form calcium silicate. Calcium silicate. Iron 3 oxide is reduced to iron by carbon dioxide. That is wrong because it is reduced by carbon monoxide, and carbon dioxide is a product of the reaction besides the iron that is produced. The raw materials are bauxite, limestone, and coke. So what's wrong here? Here the bauxite is wrong. Obviously that is bauxite is aluminium oxide. We don't want aluminium oxide. We want iron oxide, and the name of iron 3 oxide is usually hematite. So that's why, the other 3 are incorrect. So an experiment to investigate the effect of painting iron is shown. In here we have pure iron with a little bit of air and water, and painted iron, air and water. The experiment is left for 7 days. What happens to the water level in the test tubes in X and Y? So because the iron oxide, pure iron, will react with oxygen in the air to form iron oxide. Therefore, some of the oxygen is used up, which means the pressure in this test tube will decrease, and therefore the water level should rise. Now we are basically taking away gas. It's an addition reaction, iron plus oxygen, O2, to form something like iron 3 oxide. So that would be 2, something like this. And that means, gas is basically used up, and the amount of air decreases, the amount of gas in here decreases, pressure decreases, water rises. Here we have painted iron. Painted iron is protected. It will not rust. There's no reaction, so the water level will remain the same. So D should be the correct answer here. Bauxite contains aluminium oxide, and aluminium is extracted from aluminium oxide by electrolysis. So one more thing I can give you a little hint here, or trick that you can use in exams. If you come across this question here and you're just not sure what bauxite is, maybe which answer is correct, and you highlight this question, just keep in mind that you read bauxite here, and you come to questions later and the question is about bauxite, and it tells you that it contains aluminium oxide. So therefore you can go back to this question and exclude answer D, because now you know that it contains aluminium oxide, which is not in the part of iron extraction. So let's go to 30. Bauxite contains aluminium oxide. Aluminium is extracted from aluminium oxide by electrolysis. Which statement is a reason for why cryolite is added to the electrolytic cell used to extract aluminium? Cryolite decreases the rate at which aluminium ions are discharged. Well, that wouldn't be an advantage. That means the rate of aluminium production would be slower. So not A. Cryolite lowers the melting point of the electrolyte mixture. That is the correct answer. Cryolite prevents the carbon anodes being burned away. No, it doesn't. Oxygen, no, aluminium oxide is split up by the electrolysis into aluminium plus oxygen. This happens at very high temperatures, again, because we need to melt the whole mixture. Although the cryolite is added, it's still a high temperature that we're working at, and the electrodes where oxygen is formed are graphite electrodes, which means it's carbon, and at these high temperatures, these carbon electrodes then immediately react with the oxygen that's produced and they burn away, so the cryolite cannot prevent that. It will probably slow it down because, again, the temperature, the working temperature is lowered, but yeah, the main reason is to lower the melting point. Cryolite removes impurities from bauxite, it does not, so B is the correct answer here. Which statement is correct? Atmospheric carbon dioxide is not a cause of climate change. Atmospheric carbon monoxide is produced by complete combustion of carbon-containing fuels. Burning natural gas decreases the level of carbon dioxide in the atmosphere. Decomposition of vegetation causes an increase in the atmospheric methane. So, atmospheric carbon dioxide is not a cause of climate change is wrong. That is a cause of climate change. No more carbon dioxide in the atmosphere means more greenhouse gases in the atmosphere, means more heat is trapped, and climate change is enhanced. Atmospheric carbon monoxide is produced by complete combustion of carbon-containing fuels. Oh, which statement is correct? Just a moment. So that means, this is wrong because complete combustion always produces carbon dioxide by definition. Complete combustion means everything is completely oxidized, including the carbon. So not carbon monoxide. Burning natural gas decreases the level of carbon dioxide in the atmosphere. This is wrong. Decomposition of vegetation causes an increase in the atmospheric methane. So that should be the correct answer here. Because a decomposition of vegetation means the decomposing organisms respire, and that produces carbon dioxide and not methane. A plastic combusts to form... Oh, it's correct. So yes, it does as well produce methane. Yes. Why does this question confuse me so? Yes, so they are decomposing microorganisms. Many of them produce carbon dioxide, but there are decomposing microorganisms that produce methane as well in usually anoxic conditions without oxygen. A plastic combusts to form sulfur dioxide and hydrogen chloride. How could both gases be removed from the air? So this has to do with reactions of acids and acidic oxides. So this is an acid, this is an acidic oxide, and therefore it should probably be D, because calcium oxide is a basic oxide. So they will react with each other to form a solvent water. And 33, which equation represents photosynthesis? Photosynthesis is carbon dioxide plus water forming on glucose and oxygen, and the correct balanced equation is D. 6 carbon dioxide, 6 water gives C6H12O6 and 6 oxygen. Which statement defines structural isomers? Same molecular formula, but different display formula. Same molecular formula or different structural formula. Structural display, both different. So the correct definition is this. Same structural formula, definitely not. Yes. Petroleum is, now for example, I can give you the example of this, let's say butane. Butane has molecular formula of C4H10. Oops. And display formula, we can draw more easy to see. Like this is N-butane, and we can have one branching structure like this. That is our methyl propane. This here is a methyl group, and the longest chain has 3 carbons, which is propane. What is not an isomer is this. This is not an isomer. So why is this not an isomer? By the way, I'm not drawing the hydrogens. Too lazy for that. So the open bonds means there are hydrogen atoms at the end. So yeah, this is not an isomer. The reason is because single bonds are free movable. They can rotate. So this chain here is basically the same as this chain. It's a chain of 4 carbon atoms connected to each other. You can just imagine this is a rope. It's the same rope, it's just bent here. You can take this end of the rope here, and you can take this end of the rope, and you can pull it straight, and without breaking any bonds, you end up with a structure. You cannot do this with this. Because on this carbon atom here we have another bond going to another carbon atom. You cannot change this molecule into that molecule or this molecule without breaking any bonds. So that's a big difference. The structural formula of these would be CH3, CH, 2CH, 2CH3, and here CH3, CH2, and now we write in brackets, oh sorry, not CH2, CH, and then in brackets CH3, and again CH3. So what does this mean? The brackets basically means that from this carbon atom here, a CH3 group, methyl group, splits off, and then behind the brackets that group is going to be attached to this carbon atom as well, which is this one here. So these are these 2 groups, the structural formula. So we can see that the structural formula here is different from the structural formula here. 35. Petroleum is a mixture of different hydrocarbons. Which process is used to separate the petroleum into groups of similar hydrocarbons? That is fractional distillation. It's a mixture of different hydrocarbons. Different hydrocarbons means we can make use of their differences in physical properties, like boiling and their boiling points, and therefore we can use fractional distillation to separate them. Which equation representing a reaction of methane is correct. First one looks good. Yeah, the first one is correct. That is, methane undergoes halogenation by substitution. The conditions that are needed for this reaction are UV light. What the UV light does, it has enough energy to break the covalent bond between two chlorine atoms that will produce two chlorine radicals. A radical is an atom or molecule that has a single unbonded lone electron, and this makes these extremely reactive. So yeah, what will happen is that such a radical will react with the methane, and it basically steals away a hydrogen from it because it's so reactive to form HCl, and that will leave behind another radical, CH3 radical, which is super reactive and will eventually react with a chlorine, and that will chlorine molecule Cl2, so we have CH3 plus radical, that dot here represents the lone electron, super reactive, will react with the chlorine molecule, steal a chlorine, and we can see that we now have all our products, and we get another radical. If we put these two equations together, we can see that this side and this side, this cancels out, and this cancels out, and we are left with the overall equation CH4 plus Cl2 gives CH3Cl plus HCl. And that is this equation. And again, we need UV light for this to happen, for the initiation step, breaking apart the chlorine molecules to produce our first radicals. So 37. Ethanol can be produced by fermentation or by the catalytic addition of steam to ethene. Which row shows an advantage and a disadvantage for each process? Fermentation advantage. So fermentation is a batch process, but this is not an advantage because in batch processes, you set it up, and after some time it's finished, it's used up, and you have to just redo the whole thing again. So you can't really have it run all the time and producing the ethanol all the time. It's, every time you need to reset it and set it up completely new to produce a new batch of ethanol. So that's not an advantage. So that's more disadvantage. So another potential disadvantage of fermentation is that it's much slower than the catalytic addition of steam to ethene. So this is not an advantage. It's not a fast reaction. Both of these are correct. It's a batch process, a disadvantage, and impure ethanol is formed. That's a disadvantage too. And the advantage is that renewable materials are used. It can be anything that can be fermented by yeast, so any kind of leftover from biomaterial. So catalytic addition of steam, an advantage. Both of these are correct as well. Pure ethanol is formed and it's a fast reaction. A disadvantage, that is wrong. So they are finite raw materials are used. Why is that? Because ethene, an alkene, is produced from fossil fuels, so it's a finite raw material. Because fossil fuels are finite, they're non-renewable. So therefore D is the correct answer. Part of the structure of a polymer is shown. Which monomer is used to make this polymer? So if you have a question like this, you basically divide these always up into units of 2 carbons next to each other, because these are the 2 carbons that had a double bond previously between them. There's an addition polymer, and their double bonds will break, and then they will connect to each other after the double bond has been broken. So that means that always the 2 carbons that had the double bond must be next to each other, so it's always units with 2 carbons. So this is where we had a double bond before. This is where we had a double bond before it broke and it formed a new bond. And then we basically just look what's on top, what's below, and we look for that down here. So CH3 here, yes. Cl here, H here, wrong. No, so we need the Cl and the F connected to the same carbon atom. So that is the case here. So correct answer is B. And our last 2 questions for the screencast. 5 steps in an acid-base titrations are shown. The correct order is probably starting with this here. We use a volumetric pipette to add a fixed volume of alkali to a conical flask. Then we eventually add the thymolphthalein indicator to it. So answer B looks quite good already. Let's see if the rest matches. 4, read and record the initial volume of acid in the burette. That's correct. Then we slowly add the acid, yes, to the conical flask until the indicator becomes colorless, and then we take the final volume reading, and that means B is the correct order of steps. And a student does paper chromatography on a mixture of amino acids. Student sprays the dried chromatogram with a locating agent. What is the function of the locating agent? To dissolve the amino acids, to form colored spots with the amino acids, to preserve the amino acids, to stop the amino acids reacting. So chromatography is a separation technique, so there are no chemical reactions happening. Preserve the amino acids, no. So amino acids are not visible. No? They're not colored molecules or colored compounds. The locating agent is a substance that will attach to the amino acids, react with them, and then it makes them visible, and so that we can locate the amino acids on the chromatogram, which would not be possible without it. So that means B is the correct answer. And yeah, that was it. I hope I could help you to prepare for your IGCSE Chemistry tests. That was the specimen paper for 2023. And I wish you good luck for your future tests, and see you in the next screencast.